In this lecture here, I want to show you how to solve by completing this square. So it's a method that can help you solve these quadratic equations in very specific instances. It's also not one of the better methods, okay? But it helps us. The reason we teach it and we learn it is it helps us derive one of our next topics, is what's called using the quadratic formula. But regardless, I want to show you how you can use this and some ways that you can identify a problem that you'll be able to use it for. Okay, so it goes like this. If x squared plus bx is a binomial, so just, I don't know, x squared plus bx, in this case it might be something like this, x squared plus 10x, okay? So in this case, the 10 is my b. Then by adding b squared, all right, which is the square of half the coefficient of x, so what you're going to do is you're going to add 10 over 2 squared, okay? When you do this, this ends up becoming a perfect square trinomial, and it will always factor into x plus 10 over 2 squared. All right, so 10 over 2, I'm going to simplify this. This would be x plus 5 squared. And you can see this, right? Because x squared plus 10x plus 10 divided by 2 is 5. 5 squared is 25. You know, what two numbers multiply to 25 sum to 10? It's 5 and 5. So perfect, like this. Okay, so what I'm going to do is I'm going to put some problems up here that cannot be solved by factoring or cannot be solved using the square root principle, which were two of the previous lectures for this. Okay, and I'm going to show you how to use this square root. All right, so here will be the first one, and it's going to say solve by completing the square. So it's telling you to use this complete the square method here. So I'm going to look at x squared plus 8x is equal to 3. And I'm going to leave a space here and I'll explain this. All right, so notice, like, if you were to subtract the 3 over, you'd get something that looks like this. X squared plus 8x minus 3 is equal to 0. You know, there's no two numbers that multiply to negative 3, sum to positive 8. But look, you can divide 8 by 2. So what I'm going to do is I'm going to complete the square. So I'm going to take this middle term here, divide it by 2, and square it. Whatever you do to one side, now here's how you're going to solve this problem though. Whatever you do to one side of the equation, I just added this in to maintain equality, I have to do to the other side. Okay, so watch, look. By making this a perfect square trinomial, this right here will factor into x plus 8 over 2 squared is equal to 3 plus, well, 8 divided by 2 is 4. 4 squared is 16. So let me just clean this up. 8 divided by 2 is 4. And this becomes 19. All right, well, it's like, okay, well, what was the point of that? Well, now I can use the square root property to solve. So I got a square here. To get rid of the square, I'm going to take the square root of both sides. This becomes x plus 4 is equal to plus or minus the square root of 19. So I'm going to subtract the 4 over x is equal to minus 4 plus or minus the square root of 19. And this right here is the solution. Okay, so obviously you can see there was no way to factor this, so I had to solve by completing the square here on that binomial to make it a perfect square trinomial. All right, let's take a look at another one here. Let's look at x squared plus 6x plus 2 is equal to 0. All right, notice, it's like, oh, I can't factor this, right? There's no two numbers that multiply, no two integers that multiply to 2, sum to 6. Okay, so what I'm going to do here is I'm going to subtract the 2 over. Okay, so I'm left with x squared plus 6x is equal to minus 2. All right, well, I'm going to solve by now completing the square on this binomial here. So I'm going to take this 6, I'm going to divide it by 2 and square it. Whatever I add to one side of the equation, I have to do to the other. Okay, so this is going to factor into x plus 6 divided by 2 squared is equal to minus 2. 6 divided by 2 is 3. 3 squared is 9. Let me clean this up. 6 divided by 2 is 3. So this is x plus 3 squared is equal to 7, because minus 2 plus 9 gets you 7. So I'm going to take the square root of both sides to solve. So this just becomes x plus 3 is equal to plus or minus the square root of 7. And then I'm just going to subtract the 3 over. So x is equal to minus 3 plus or minus the square root of 7. So just so we're clear, I didn't do this in the previous example, but you know, you have two solutions here, right? All right, so that's how you use the completing the square method here. And it seems a little weird or difficult at first, but you know, if you practice it a few times, it's actually not too bad. And it's really useful when this number is an even number and you can divide by 2. Then you can solve this stuff rather quickly.